Hi, so this particular topic, drawing Lewis structures, was a request that we got from one of our students online here, and it's about drawing Lewis structures. So I'm just going to give an overview of how to do it. And then I have some examples there in the green. You can see them. We're going to try that out as well. Well, here are the steps, okay? If you want to draw Lewis structures, follow these 4 steps. Step 1 is to calculate the number of valence electrons that you have in the compound. So for instance, in that example that we have CCl4, that is tetrachloromethane, we want to get the number of valence electrons that it has. Next is to arrange the atoms and draw bonds connecting it. And then the third thing to do is to calculate the valence electrons, complete rather, the valence electrons on the outer atoms first, and then you complete in the center. While doing this third step, you would want to ensure that you have an octet of electrons, and by that I mean 8 electrons. So this one, you just need to draw it out, calculate the number of valence electrons, put it together, and then start arranging your lone pair of electrons around it. When you do this, you find out that this is tetrahedral and the bond angle is 109.5. In some places it's 109.25. Right, so let's look at NH3. NH3 is ammonia, and the usual way, nitrogen is in group 5, so that's 5. And here we have 3 multiplied by hydrogen. We're going to pick the number of valence electrons of hydrogen as 1. Okay? Quick update here. Hydrogen is not actually in group 1. They just place it there. In some periodic table, they actually put it separate from the group 1. And we'll talk about the reason another time. So this gives you 8. Yes. And then when you arrange it, you have nitrogen here, hydrogen here, and you could just put the last one down here. So let's see, 2 electrons form a bond as we said earlier on. So this is already 2, 4, 6. And now I have to get to 8, so the remaining 2, I'll place it here. That is where this step 3 comes in. Complete the valence electrons on the outer atoms first, and then in the center. So that's in the center here. We call this lone pairs of electrons. So we're striving to get an octet, meaning that we want to have each of them having 8 electrons around them, apart from hydrogen, that is because hydrogen needs just 2. It only attains a duplet. Right, so this is the structure of ammonia, the Lewis structure, and because of this arrangement, it is best regarded as trigonal pyramidal in shape. There's a difference between geometry, that is electron geometry, and molecular geometry. It is the molecular geometry that I have written here, which I am calling the shape, the actual shape, okay? But electron geometry is different from molecular geometry. There's also a topic for another day. We're just learning how to draw the Lewis structure in this particular one. So let's check out the third one, which is CO2. Okay, here we go, CO2, and this one is really interesting because you're going to see what step 4 is about, using multiple bonds where necessary. Okay, so how do we start off? Yes, we look for the number of valence electrons. Carbon is 4, oxygen is in group 6 or 16, but eventually it has 6 valence electrons. So we have 4, and then we have 6 times 2, 12 plus 4, that's 16. Okay, now let's arrange it. We have 2 oxygen atoms, we have 1 carbon atom. It's very likely that carbon will be in the center, and then your oxygen will be at the extremes. The second thing you want to note here is that it is the element that is least electronegative that would be in the center. So this will also help you when you want to determine which one stays in the center, okay? So that's carbon. Yes, let's drop 16 electrons around it. There's already 2 here, 4 here. So we need to do more stuff. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It looks complete, right? It's just that the carbon is not happy, as I usually say. So let's move these 2 electrons to form a bond here. And and that would mean that you have a double bond here. If we do the same thing here, this comes in like that, and then we would eventually have something of this nature. Yes, and then you only have 2 lone pairs left on each of these sides. Now this is the Lewis structure of CO2. It looks so balanced because what you have at this point basically is similar to what you have at this point. The polarities here cancel out and the shape is linear. So this is your structure, the shape is linear, and there you have it. Okay, let's work on drawing Lewis structures for ions. So the first ion we're dealing with here is CO3 2-, which is called a carbonate ion. It's an anion. We want to get the number of valence electrons first, so carbon is 4 plus 3 into 6, and then this 2- here means that it has gained an extra 2 electrons, so that means we have to add an extra 2 to this. Okay, if it's positive like this, it means it has lost 1 electron in this case, but here it has gained 2. So sum this up, this is 18 plus 2, that's 20, and this is 24. So that gives us a total of 24. Now let's arrange this. We want to put carbon here, we want to put oxygen, 3 of them, 1, 2, 3. So we want to start with that, and then let's see how it goes. So far we have 2, 4, 6, we're heading to 24. So let's continue. 7, 8, 9, 10, 11, 12, 14, 16, 18, 20, 22, 24. Now all my electrons have been placed, but the carbon is not happy. So I have to do something about it. It's either I bring this one here, right, to get a double bond at that area, and if I have a double bond here, it will mean I'll be having something like this: carbon, double bond here, single, single, meaning that around carbon I'll be having 4 bonds, which corresponds to 8 electrons, which is good. So I could bring this lone pair of electron here. I could also bring it from this area, or I bring it from this area. So I just need to do only one, but you can see that the 3 of them actually works, and that leads us to what we call resonance structures. Okay, so I'm going to erase this now and do it this way. Double bond, yeah. And this is one of the resonance structures of this. Okay, and that's what you have. The shape will still pretty much be trigonal planar because you have a double bond here. Whenever you see a double bond around the carbon and an oxygen here, this area translates to a trigonal planar shape. Okay, we'll deal with shapes in depth later on, so you're going to understand how to determine the shapes, and also you will understand the difference between molecular geometry and electron geometry. Those are like likely questions, so we're going to deal with that in subsequent videos. All right, so have fun, guys. We're going to head over to H3O plus next. Okay, so I realize I've not used the black ink for a while. That's pretty awkward. I usually use black ink almost lots of videos, and then the red, because I like red and blue as well. Okay, H3O plus, we want to draw the structure. What is the first thing we'll do? We'll get number of valence electrons. Yes, so we have 3, hydrogen is, we're giving it 1, plus oxygen is 6, and then there's an extra that will be taken off because this is positive, meaning we've lost 1 electron. So that leaves us with, this is 6 plus 3, 9, minus 1, 8. Okay, so how do we do this? We said the least electronegative stuff should be in the center, but in this particular case, we're going to circumvent that rule and do it this way, because we cannot have hydrogen in the center. Okay, hydrogen is never really in the center. So in this case, we're bringing an oxygen here, and then we're putting hydrogen outside. HH, and okay, let me just drop the last H here. So how many have I done so far? 2, 4, 6. I'm heading to 8, right? So I should have remaining one here, 7, 8. Make sense? Exactly. But I cannot conclude this video without putting a square bracket here and putting a plus outside, because that shows us that it is an ion. So this is how you draw the Lewis structure, and that also tells you that in the previous example for the carbonate, I also needed to have put 2 minus outside a square bracket. So that means that we will be having something like this after you draw your C, double bond O, single bond O, single bond O, and then you do it this way. You're going to have a 2 minus outside, okay? You show your electrons around here, yes, and then this will just have 2 left, but then you need to put that 2 minus outside. It's very important, okay? So that brings us to the end of the introductory parts of drawing Lewis structures. Later on, we're going to talk about the shapes, how to know the shapes, how to know that the H3O plus is a tetrahedral shape, and other things as well will follow. So stay tuned, and if this is your first time of seeing us, just hit follow. It's right there, somewhere around there. Just hit follow because you'll be learning a lot. Okay, and of course, feel free to reach out via DM if you have any problems in chemistry. We'll see how we can help you out. Okay, so have fun.